Okay, this is 2.7 part 2. We're going to talk about type 3 and type 4 equations. So this is measurement and missing dimensions. So the first one we're talking about here is area. Area is always length times width for a rectangle. So what is our expression? That's what we want to find out. Well, it's going to be length times width. So I'm going to take this guy and I'm going to multiply it by that guy. So as I write it down, the first thing I'm going to do is I'm going to factor it. So first thing that's going to be factored, out of the top here, I can take out a 2x squared, and I'm going to have an x plus 2 left over. On the bottom, I still have a 5x. Okay, and that's going to multiply by the second side. And the second side has a 20x on the top. And on the bottom, it's got x plus 2 squared. What that means is there's 2 of them. So write them out and expand it, because otherwise you're going to forget how many you have. All right, now we can only start canceling things after we've done our non-permissibles. So our non-permissibles, this is only multiplying. Multiplying non-permissibles only come from the denominator. So on the bottom left, what can't be 0? Or what can't be x? 0. On the right, -2. I gave you the answer, of course. So x can't be 0 and -2. Perfect. All right, what can I wipe off?
X plus 2.
The x plus 2, good. Now how many of them can go? Only one of them. If you have more than one, you can take out only as many as you see. Okay, so 1 on the top removes 1 on the bottom. It doesn't remove both. All right, on the top, I've got x squared and x to the 1. On the bottom, I've got an x to the 1. So my x exponent 1 can be removed. And what do we know about 5 and 20? They both reduce by 5, correct? So we're going to divide them both by 5. This guy becomes a 1. This guy becomes a 4. Now we multiply everything that we've got left over on top. So we need to highlight what's left over. We've got that guy and that guy on top. That's all we have left on top. So the 4 and the 2, you're not going to write them side by side. You're actually going to multiply them. So we're going to have 8x squared on top. And on the bottom, we're going to have an x plus 2. Okay, that is the answer for A. Now B says, what if x is 3? How big is it? Well, now we're going to substitute in x for 3. Now there's a couple different ways we can do this. So everybody grab your calculator, and I'm going to show you how to store x again. So we're going to store x in the calculator. And right now I want x to be 3, because that's what the question's telling me. So in order to do that, you're going to hit 3. The store button's above the on. Hit the store, and then x, and then enter. And now what we're going to do is we're going to type in the top, 8x squared. So 8x squared, enter. Now we're going to hit divide by. And now we're going to put in brackets x plus 2. Bracket x plus 2 bracket. Now it's going to insert that 3 and add it and then divide. We're going to get 14.4. So our answer for this guy is 14.4. So here we've got a shape question. They're talking about the degrees of the angles inside the shape. So it says, the measurement of degrees at each angle of a regular polygon is given by this equation. 180 minus 360 divided by number of sides. N is the number of sides. What is the measure of each angle with 15 sides? So literally we're putting a 15 where the N is, and we're solving. So we're going to write D equals 180 minus 360 over 15. We're putting 15 where the N went. And that's going to give us 180 minus 24 which is going to give us 156 degrees. Okay, 156 degrees. So B now tells us every angle is 162. So then how many sides does the polygon have? So now we're going to be solving for n, and we know the D number. So we're going to be going 162 equals 180 minus 360 over n. That's how we're starting that side. So this is a typical equation where you've got to isolate the variable. So when we're isolating variables, or taking things across the equal sign, we do reverse BEDMAS. So BEDMAS, the bottom two are adding and subtracting. So if anything is being added or subtracted to the variable, they have to remove first. So that means this guy here, he's being added to this guy. So that means I got to remove the 180. So I'm going to subtract 180 because I want that n by itself. So now that's going to give me negative 18 equals negative 360 divided by n. Now if I want to get anything off the bottom of a fraction, the fraction line means divide, so I'm going to do the opposite, and I'm going to multiply. So this guy is multiplying by n, so this guy multiplies by n. So now we've got negative 18n equals negative 360. We need them both to be negative so that when we divide them out, they become positive. So now we're going to divide out the negative 18. And like I mentioned, everything negative divided by a negative is going to give us a positive answer. So n is how many sides here? 20. Good. So we end up with 20 sides for that polygon. If every angle is 162 degrees. So some of the questions are just plugging numbers in. Some of the questions are actually manipulating them. Our last two are dealing with area and volume. So, example 4, your example 4, my example 3. Yes? Okay, so the biggest thing about this is we're dealing with basically a Kleenex box. Okay, that's what this is. It's a rectangular prism. So something that looks like a Kleenex box, or just any regular box. So, the area of the base times the height is how you find it. Length times width times height. So, area of the base times how high it is. So, this is what they've reminded us. They've told us the volume. They've told us the area of the base. They want to find the height. So, it's all about rearranging this equation. So, if I want to find height, height is going to be volume divided by area of the base. Okay, that's our first thing. To rearrange it. This is your number 4. Alright, so we've rearranged the equation. Now we're going to plug in where everything belongs. So, carrying this over, on top we would have 20x minus 12 over x minus 3. Dividing by, we're going to write it left to right versus top and bottom. We're writing it left to right so that we can flip the right-hand side. Remember, because when we divide, we flip and times. So this guy here, area of the base, 5x minus 3 on top of, I'm going to factor out a 2 there, x squared minus 9. Okay? So I GCF the 2 real quick there.
Can you not pull 2 out of the 20x minus 6?
Yeah, you betcha. So 20x minus 12, we can actually GCF a 4 out of there. So now that I've written my statement for height, I need to now factor everything. Okay, so first step, write it out, factor, non-permissibles, and then solve. So, factors, next step. So step 1, write it out. Step 2 is factor. So at the top here, I'm taking a 4 out, and I'm going to get 5x minus 3, all on top of x minus 3. On the right-hand side, I am now going to take the divide sign and I'm going to change it to a timesing. So I'm changing it to timesing, but when I do that, I got to flip this guy upside down. So now the 5x minus 3 is on the bottom. And I've got a difference of squares here. X squared minus 9. So that's going to break down into x plus 3 and x minus 3. Typically what you want to do is look at the other parts of the equation that are already factored and given for you. So the left-hand side here, I have a 5x minus 3. I'm looking for something on the right that might factor to that. And yes, something did. Same thing on the left. I have an x minus 3. On the right, something factored to give me an x minus 3. Okay, so it kind of helps and gives you hints. So now that I've got everything factored and flipped, I have to do the non-permissibles. So step 3 is NPVs. All right, what can x not be? Now remember, for non-permissibles, I need to take the bottom and the top right. Okay, because the guy on the right was flipped. So you have to take the whole thing. So bottom left, positive 3. Bottom right, 3 over 5. If you got a number in front of x, it's the bottom. So x cannot be positive 3 over 5. Okay, and then up here on the top right, plus and minus 3. Over here it was plus 3. We need both. So plus and minus 3. So step 3 was NPVs. We got her taken care of. All right, so step 3 is done. Now we can just cancel all the common factors. So what is something I can wipe off right away? 5x minus 3. Okay, it's gone. What else can I wipe off? X minus 3. So do I have a denominator anymore? It's a hidden 1. Okay? So now you've got 2 numbers on top still. You're going to multiply those. Okay? So if you still have coefficients, you have to multiply those for your final answer. So our final answer for height is going to be 8 times x plus 3. There's nothing else we need to do that question. It's going to be 8 times x plus 3. If you want, you can show the hidden 1 on the bottom, but you don't have to. Okay? Any questions on that kind? Yep. No, you don't have to show that. No. Okay. Next one, last one on your page there. This is your number 5. So they've given the height and they've given the area of the base. So if they want volume, you take area of the base, multiply by height. So you're just going to multiply these guys. So first step, write the actual multiplying equation. So volume equals area of the base times height. And that's what I have to multiply. So volume equals my area of my base, 6x exponent 5 minus 96x exponent 3. On top of 5x to the 4th minus 20x squared, timesing by the height. 3x to the 4 plus 6x cubed. All on top of 2x squared plus 8x. So, these are very typical questions that you're going to see, where all you've got to do is GCF. The most basic type of factoring is greatest common factoring. And that means just divide something out of both terms. And that's the one that many forget. Okay? And that's your basic kind that you'll see everywhere. Alright. Out of the top left, what can I remove to factor?
6.
I can take a 6 out. How many x's?
3.
Good. So 6x cubed comes out. I get x squared minus 16. That's going to give me a difference of squares right there. Okay? What can I factor out of the bottom of that guy?
5x squared.
A 5x squared. Good job. That's going to give me x squared minus 4, another difference of squares. So this is typical. Okay? Now we're going to take this part. We're not even going to do the right-hand side yet. We're going to take this part and go one step further. So now we're going 6x cubed 5x squared. So I'm saying going further, what do I mean by that?
Oh, the square root.
That's right. These are difference of squares, which means you can square root them and open two brackets. Okay. Yes. Move up bit, sure. Okay. So, square root of 16, 4. So we're going to have x plus 4 and x minus 4. What is the square root of 4? 2. So we're going to have x plus 2 and x minus 2. Perfect. Now we're going to go back up and we're going to do the same thing to the right-hand side. Okay, I'll give you a moment to write that down. Here we go. So now we're going to take a look at the 3x exponent 4 and 6x exponent 3. The only thing there I can take out is 3x cubed. So we're timesing by 3x cubed. I have x plus 2 left over. And the next one, all I can take out is a 2x. And all I have left over is an x plus 4.
There, that's when you can't.
Okay, there wasn't anything extra I could
No.
factor there, so that is going to come sit down right inside this guy. Okay, so I'm just going to clone him and make him go below.
You're asking me for no cancel. I told you to also the same.
Yeah, like plus minus would be cancel, right?
Yeah.
There you go. Plus 2 and minus 2, then I'd cancel.
No, minus 10, they're the same. So you think you had it right before.
Okay,
I thought you right about
timesing and timesing. Okay, everybody's got it written down? So this is where we're at now. Now we're at the step where we need non-permissible values. So, non-permissible values come from only the bottom. This was not a dividing sentence. This was not a dividing question. So, bottom left, beside the 5, what can't be x? 0. In the brackets. Plus and minus 2. Over here, beside the 2, 0. In the bracket. Only negative 4. So we're going to say x cannot be 0, plus and minus 2, and negative 4. Okay, those are the only things x can't be. Now we're going to start to scribble things out. All right, what's the first thing I can scribble out? What do you think? An x plus 2. Okay. X plus 2 is gone. X plus 2 is gone. What else can go? X plus 4. X plus 4 goes. All right, what about our x's? Just single x's. Okay, I got 3 here, 2 below. How many can go? 2 of them. So that means this guy's now a 1. X to the 1. Okay, on this side, how many x's can go? Only 1. So this guy's going to be now a 2. X to the 2. Okay, we are now going to multiply. We're going to multiply the coefficients. So 3 times 6 gives me 18. How many x's are left over on top? I have 2 with this guy, 1 with that guy. So that's 3. X cubed. I have a bracket left over. X minus 4. All on top of 2 times 5. 10 beside x minus 2. All right. So I'm just highlighting everything that was left over, because everything that was left over has to multiply. That's what we end up with in our bracket, in our final answer. Okay? So, is there anything else I can reduce? Yes, what can I do? 18 and 10 both divide by 2. He becomes a 9, he becomes a 5, now we're fully reduced. Okay? This will be your final answer now. There's no other possible answers. Okay? So the 18 becomes a 9, the 10 becomes a 5, we're done. Okay?
Yeah.
Any questions with those? Okay, last 2 examples. Type 4 is a money question. You've got a very similar question to this in your assignments. So, this one they have shown us and created the equation for us. So So we've got Ben buying a case of t-shirts with 5 different varieties for $750. Kept 5 different t-shirts for himself and sold the rest for $900, making a profit of $15 on each shirt. How many t-shirts were actually in the case? So we're letting X be the number of t-shirts in the case. The buying price is $750 divided by the number of shirts. Selling price, $900 he sold them for. Number of shirts minus 5 that he kept. And that's what we're going to keep. And then it says 15. So it's equaling 15 on the right-hand side, because that's what they have told us. Okay? Now, we take the rational expression. We want a common denominator. What would your common denominator be there, guys? Both of them are different. If they're both different, you must use them both. So right now we've got this. 15 equals 900 over x minus 5 minus 750 over x. And this guy's over 1.
Will they always give you the equation?
Yes.
Okay.
They never ever will ask you to create it. The upstream, downstream ones, they might give you a chart and then say create it, but they're going to give you all these things. You just literally have to fill them in. Okay. All right. So our common denominator, this is a binomial. So we need both bottoms. We need the x and the x minus 5. So this is the way we write it. This guy has x minus 5. This guy has x minus 5. This guy has x minus 5. And now I multiply the top what was missing. This guy had a 15. All right.
Isn't it 750?
What was the... Oh, 750, thank you. I wrote it wrong. 750, thank you. Okay. What did the 15 need?
Why do you need the x and x minus 5?
Because this guy's considered a binomial log. If it's a binomial by itself, you can't just say, oh, this guy just needs the negative 5. Okay? It's an actual binomial, so he needs both of them together. It has to go as one item. Yeah. Good question. All right. So 15 is missing both things on the bottom. So he needs both. What does the 900 need? What's he missing?
Nothing.
He's missing x. What's the 750 missing? The x minus 5. At this stage, now that we've got the top changed, we do non-permissible values. So, NPVs, what can x not be? 0 and 5. So x can't be 0 and it can't be 5. Now the bottom's gone. We can erase it. Okay, bottom is gone. All we got to do now is multiply into the brackets. So this is 15x multiplying in. So it's going to be 15x squared minus 75. I think. Yep. 75x equals 900x minus 750x, and here you've got a negative times a negative. That's going to be the one that catches everybody. The negative times the negative is a positive answer. So this is going to give us a positive, it's a fake number, 3750. So that ends up being our equation. So we need to add the x's on the right-hand side together before we can move everything to the left. Why do we have to move everything to the left? X squared. If you've got an x squared that does not cancel, that means you have to move everything to the side where x squared is positive. He's positive on this side, so that means everything on the right has to move left. So we're going to add those together, and that's going to give us 150x. So we have 15x squared minus 75x equals 150x plus 3750. Now all of that is going to the left. So because it's going to the left, we have to do the opposite. So this guy is a positive 150, we're going to subtract 150. It's a positive 3750, we're going to subtract 3750. So subtract 150 to the x, subtract 150, x's, this guy can now disappear. Subtract 3750, I need to subtract 3750. So now, everything has disappeared on the right-hand side. I'm going to add just the x's on the left. That's all that's the same. I can only add the x's on the left. And then I'm going to stretch it out, x squared, x, and the constant. So we're going to get 15x squared minus 225x minus 3750 equals 0. No, she's just adding like terms. Yep. Now we're going to divide out 15. You're going to divide out a GCF. You want to divide out the guy that's in front of x squared always. Okay, because we want to try and just get a 1 in front of x squared. So if everything divides by 15, which it does, you take out a GCF of 15. So then we get x squared minus 15x minus 250 equals 0. Now we can do a diamond on that guy. We're going to get 25 and 10. So we're going to get, just for a final answer, 15, x plus 10, x minus 25 equals 0. Now we got to pull them out of brackets to see what x is equal to. So we want to find out how many t-shirts were in that case to begin with. And that's what it's going to tell us. So when I pull x plus 10 out of brackets, what's that become? Negative 10. In problem solving, am I allowed a negative answer? No. So we cross this guy off and say he's not a possible solution. So we're not allowed a negative answer in problem solving. The next guy comes out as a positive 25. He is the only solution. I do check my non-permissible just to make sure they don't match. My non-permissible is positive 5. It doesn't match, so this is a possible solution. So we say there were 25 t-shirts in the case. Okay, 25 t-shirts in the case. The next question, they're going to give you the problem-solving situation. They're going to give you everything set up, including the equation. So you're not going to have to figure out how to do the equation. They're going to give it to you. Okay, I'm just going to raise this up a little bit. Get caught up. Okay, well, last question here. So, total price, $80. So it says, Carol's in a business selling souvenir pens. She purchased a box of pens for $80. She kept 5 for herself and sold the remainder of the pens for a total of $105, thereby making a profit of $1 on every pen sold. How many pens were in the box initially? So, the purchasing price was $80, selling price $105. Price per pen, we have no idea. That's what we're figuring out. Number of pens, we don't know. The selling price, we have to subtract 5 that we're keeping ourselves. So the price per pen is going to be price divided by number of pens. And that's what they're showing here in that little triangle. Okay? So it's showing that we have to divide them. So the equation is going to be this. Purchase price per pen plus $1 that she wants profit off each pen. Okay? equals the selling price per pen. And then we've got to write that down. Okay. So, purchase price, $80. We don't know how many there were. Plus $1. Selling price per pen is going to be 105 over X minus 5. So we have the same common denominator in this case. We have X and X minus 5. This is 1 over 1 as a digit. 1 over 1, you make it into a fraction. So, our common denominator is X and X minus 5. So this guy is missing the X minus 5. This guy is missing both, the X and the X minus 5. And this guy is just missing the X. Okay? Now we can do the non-permissibles. What are the non-permissible values for our question? What is X not allowed to be in the bottom here? 0 and positive 5. Same as last question. 0 and 5. Now that we've converted the top, we can get rid of the bottom. It doesn't exist anymore. So, bottom is gone. And I'm going to rewrite it. So now I've got 80 times X minus 5 plus X times X minus 5 equals 105 X's. And now we multiply in the brackets. So we have 80X minus 400 plus X squared minus 5X equals 105X. X squared is positive on the left already, so that means we need to move the 105X to the left. So this guy's going to move that way because X squared is positive over there. So we're going to subtract 105X's here. We're going to subtract 105X's here. All right. On the left-hand side now, let's see what we end up with. We have all these X's we have to add together. So I've got 80X, subtract 5X is 75X's, subtract 105. That's going to end up with a negative 30X's. So we're going to end up with X squared minus 30X minus 400 equals 0. That's after we add all those X's together. Okay? And then we diamond that guy out, we're going to get 40 and 10. So X minus 40, X plus 10 equals 0. Are we allowed to have negative answers in problem solving? No. So this guy comes out as X equals negative 10. We don't use it because we can't have a negative answer in problem solving. This guy comes out, X equals 40. So there were 40 pens in that case to begin with. Okay, don't forget though, we can't use the negative answer as part of our solutions. Yep. Because the negative is not possible in problem solving, remember, okay? That concludes part 2 of 2.6 problem solving.